Hello everyone, today we will talk about the greedy techniques. So greedy technique is nothing but the minimum cost spanning tree we will be finding out. So we are having the with cost minimum cost spanning trees. We will be using Prim's algorithm, Kruskal's algorithm, Dijkstra's algorithm. So last semester already you have learned about the BFS, DFS without cost spanning trees, but here is we'll be learning with cost problem trees. So let us see the applications of the minimum cost spanning trees. So here maximum will be using the network design like TV cables, roads, and NP approximation problems also will be solving. So in this traveling salesman problem, assignment problems, and knapsack problems. So apart from that we will be learning the clustering analysis also. Now let us start the Prim's algorithm and Prim's algorithms problems, how to solve it. So first one is called the Prim's. So second one is nothing but the Kruskals. Third one is nothing but the Dijkstra's. So now we will talk about the first one is called the Prim's algorithm. So Prim's algorithm, first I will write the problem. So A, B, C, D, E, F. So A to B 3, A to F 5, A to E 6, B to C 1, B to F 4, C to F 4, F to D 5, C to D 6, E to D 8, finally F to E 2. So this is the problems. Using the Prim's algorithm we will solve how it will be working. The solution is right. So now let us solve the solution for this. Solution we have to solve it. So here we are using the spanning tree we are drawing. Spanning tree is nothing but spanning tree is also tree which we should not have any cycles in the tree. So here is suppose trees is nothing but if I start from the A, again I can reach back to A. So when we are drawing the spanning tree we should not have any cycles, such a way that we have to do it. So now Prim's algorithm using the solutions. So here first one is called the tree vertices. First one is called the tree vertices. Second one is called the remaining vertices. Spanning tree. So first one is nothing but the Prim's algorithm, always we have to start from the first node. So that is nothing but the two ways we can write it. The first one is nothing but the A. So the remaining nodes is nothing but we are having A to B 3, A to F, A to B 3, A to F 5, A to E 6. So these are all the outgoing degrees from the A. So when we are drawing the spanning tree, what we have to do is which is the minimum out of all these things. So we have 3, we have 5, we have 6. So always the Prim's algorithm we have to start from the first node. So what we have to do is A. So from A 3, 5, 6 outgoing degrees are there, which is the minimum. So that is called the 3. So we have to draw the spanning tree is nothing but A to B. This is what the 3. So now next is nothing but the visited node is nothing but 3 vertices is nothing but the A to B is equal to 3. So this way one we can write it, or this B of A is equal to 3. So both the ways we can write it this one. So either you can write this way or this way. Now what you have to do is second one. So second one what you have to do is the remaining notice. So here you have recently visited is called the B. So B what will happen is, so you have the B to C 1, B to F 4. So you have to start from the B, B to C, B to F. So write it that one first. So here is A to B we have traversed. So now B is the visiting node, you have to write it here. B to C is equal to 1, B to F 4. So now what you have to do is, out of all these things, which is the minimum element? So you have visited, this one is already visited. Now remaining is 5 is there, 6 is there, 1 is there, 4 is there. So 1 is the minimum. Now what you have to do is, you have to draw from the 1. So A to B already is there, that is nothing but the 3. Now B to C is called 1. Okay. So now what will happen? The recently visited node is nothing but the B to C. Write it now, that is called the B to C is equal to 1. Now recent visited is nothing but the C node. So C node is nothing but C. So now you have to select from the C node what are the outgoing degrees are available. C to D 6, C to F is 5. That you have to write it now here. C to D is 6. Next C to F. C to F is 4. So now B to C visited now. Now out of the all visited nodes, which is the remaining, the element is called the minimum element. Now you have 4 is there, 4 is there. So what you have to do is, now which one to be taken? When you are taking the adjacency matrix, B will be coming, B to F you have to draw it. So now draw the spanning tree here. A, previous diagram as it is, you copy it here. A to B 3 is there, B to C 1 is there. Now you have to take B to F. B to F is 4. Now write it here, B to F. B to F is equal to 4. Right. Now what will happen is, recent visited node is F. So from F, what are all the outgoing degrees are available? Now just to see the diagram here. So F. So F outgoing degrees is nothing but F to B is there, F to C is there, F to D is there, F to E is there. But already you have written A to F you have written, B to F you have written, C to F you have written. The remaining nodes you are having F to D, F to E. That you have to write it now. Write it here. F to D, F to D is 5. Another one is called F to E is equal to 2. So now what will happen? Out of all these things again, which is the minimum? So which is the minimum is nothing but 2. So now 2 is nothing but F to E. You write the diagram, that one F to E. Write it. So now what will happen? F to E is the minimum. So write it the diagram, previous diagram as it is. A is there, B is there, C is there, this is 3, this is 1, this is F, this is nothing but the 4. Now you have to write F to E is the minimum. Right. Now what you have to write is, F to E is recently visited node. So now what will happen? From E, what are all the outgoing degrees, you have to write it. So now E to A already you have written. Now remaining is E to A, E to D. E to D is equal to 8. Now out of all these things, which is the minimum, you have to find out now. So now see here, out of all these things, which is the minimum element? So now which is the minimum element is nothing but here 5, 6 is there, 4 is there, C to F. So C to F, if you draw this, you will get the cycles. So this is not possible to take. C to F is not possible to take. Next, which is the remaining element? So remaining element is nothing but 5 is there. So 5 is nothing but F to D. Can take this. So this is for the final diagram. So now you have to write the final diagram. Write it here. So here I will write it, A, B, C, F, E. This already same diagram copied here. 3, 1, 4. This is called 2. The remaining sorting element is called the D. So now what will happen? The remaining you check it out now. What all the nodes are available? Right. So now 5 you have taken. So 5 also you have taken. Now check it out the remaining vertices. What are all there? So suppose if you write A to F 5. A to F 5 if you write, what will happen? Cycle you will get it. It is not possible to take. A to E. A to E if you take, that is also called cycle. Next is nothing but C to D. C to D if you draw, what will happen in the final diagram? You will get the cycle. So it is not possible to take anything. So this is what the final spanning tree. So spanning tree is also a tree which we should not have any cycles. Suppose if you draw with A, start with A, if you are going to any other node, again you cannot come back to the node. So cycle it is not available. This is what the minimum cost spanning tree. So now you have to write the minimum cost. Minimum cost is A to B 3, B to C 1, B to F 4, F to D 5, F to E is equal to 2. So now the minimum cost is nothing but 3 plus 1 4, 4 plus 4 8, 8 plus 5 13, 13 plus 2 15. So once again you can count it 7, 11, 12, 12 plus 3 15. So this is what the minimum cost. For this now we have to write the algorithm. So I hope you understood this. So right. So this is what the diagram. So this is what the tree. For this we have drawn the spanning tree. Spanning tree is also a tree which we should not have any cycles. So now what you have to do is nothing but we have to write an algorithm for the Prim's algorithm. So how to find out the minimum cost of the spanning tree? So to implement the algorithm, let us see that one. Now always you have to start from the first node only algorithm. So let us move to the algorithm. So algorithm is very simple. So let us see the algorithm here. So the name is nothing but Prims of G. So G is nothing but the graph. G is nothing but the graph. So graph is nothing but a set of the vertices and edges. So write it here, a weighted connected graph set of the vertices and edges. So that is nothing but the, you can say this is called the nodes, this is called the edges. So now you have the input values also in this. Input is nothing but the weighted graph. Next, so output is nothing but the ET is the set of the edges, composed a minimum spanning tree. Now initially you take the vertices. Always I told you already you have to start from the first node. So first node is nothing but the V0. Next we have to take the E of t. This is nothing but the edges. So edges we have not drawn anything initially, that one will be taken called the 0. So we can write it called the pi or 0. Next one is called the, we have to start from the for I is equal to 1 to modulus of V minus 1 do. So you have to take one loop and we have to find out which is the minimum of the V0. So initially what we have done is nothing but the V0 you have taken. From that we have to take the which is the minimum node. So I will show you here. So initially what I have done is nothing but the here. So I have started from the first node. So that's why V0 we have declared. In this, which is the minimum element outgoing degrees we have to find out. That means what? A to B, A to C, A to D, A to E, A to F. Out of all these things, which is the minimum element that we have to find out. For that we have to write the loop. So now write the, how to write the loop is nothing but find a minimum weighted edge E star is equal to V star comma U star. Among all the edges V comma U such that V in VT and U is in V minus VT. So this entire meaning is nothing but what? Find a minimum edge E star is equal to V star comma U. That means what? So A to B, A to C, A to D, A to E, A to F. So in the adjacency matrix, the first row, which one you have taken the visited node, that one you have to get the minimum element, such a way that you have to find out the minimum cost of the element. So now what will happen? Write it, V of t is equal to, so previously visited node V of t union of U star. So this is called the union Vt, that one. So what will happen is nothing but I will show you here now. First row I will show you one example. A to B, B is the minimum we found it. So B we have to add it to the union. So that means what will happen? A and B is called the visited. So next time what will happen? From the A, here I have written A to B is nothing but the 3, and you have written B to C, B to F elements. Now what you have to do? This is called the all visited nodes. So out of all these things, next time we will be adding which is the minimum element. So in that case what we have done? B to C we found out. So that is what the minimum element. That is the way of the writing the spanning tree. Now let us complete the remaining things. So now what will happen is ET is equal to ET union E star. So that means U comma V, whatever you have done it, that you are making the union T. Now written E of T. So this is what the spanning tree for the Prim's algorithm. So I hope you understood the Prim's algorithm, how to write and how to write the algorithms. So what will happen is nothing but this is what the graph, and we have written the spanning tree. Spanning tree is a tree which we should not have any cycles. So algorithm also we wrote it. So now algorithm we have to convert it to the program. Now I will be solving the second one, Kruskal's algorithm. Same diagram I will take. Kruskal's algorithm, it is easy to solve it, but I will tell you how it will work out. Kruskal's algorithm. So I will take the same diagram, A, B, C, D, E, F. Write the values. A to B 3, this is 5, 6, 1, 4, 4, 2, 8, 6. So all the edges values to be given, otherwise we cannot solve the problem. So now same diagram we have taken. Using Kruskal's algorithm also we will solve it. What is the minimum cost we will be getting? We will see it. Alright. So now this is very simple here. So now how to write it is nothing but. So first one is called the write all the values. So all the values how to write is nothing but. So edges you write it. I will write edges and cost. So edges is nothing but A to B. A to B is 3. Next is A to F. A to F is 5. Next is A to E, 6. Similarly, write the B to C, B to F. B to C is 1. Next is B to F. B to F is 4. Next, similarly write it from the C. C to, this is called 4. Right. Now from C you write it C to D, C to F. C to D is 6, C to E. C to E is nothing is there. C to D, C to F. C to F is 4. Next, from D to C you have written, D to F is remaining. D to F is 4. Next, D over E. E to one more is there, D to E also write it. 8. Next, E to F. E to F is 2. So first step is nothing but this one. Now second step what you have to do is, this is nothing but very simple. We have to write it in the ascending order. So I'll write the ascending order this. Right. So ascending order for nothing but first one is called the B to C. Write it once again. B to C. B to C is 1. Next minimum element is nothing but E to F. How much? 2. 1 over 2 over. Next is nothing but the 3. A to B. A to B is 3. Next is nothing but 4. 4 is nothing but C to F. C to F is 4. D to F 4. So now this is also over. This is also over. And one more also is there, B to F. B to F also 4. Now this is also over. Now what you have to do is remaining element. So remaining element you are having A to F. A to F is 5. Now this is also over. Now the remaining is nothing but the 6, A to E. 6 over, this one over. Next C to D. C to D is 6. So now we wrote it all ascending order. So once you can count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So one more left out. So D to E. So now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now you can count it in this also. 10 is there or not? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now exactly matched. Now what we have to do is, we have to write the spanning tree for this. So now how to write the spanning tree is nothing but very simple here. Prim's algorithm, always we have started from the first node. But in this case what will happen is, which is the minimum cost that to be selected first. Now B to C to be selected first. Now this to be selected. Now you have diagrams is nothing but A is there, B is there. So now A to B. A to B is nothing but 1. This is what the step 1. Now second one what you have to do is, second one is nothing but E to F. So E to F we have to draw it. So now write it according to the original diagram only. So because again I cannot go up. So A is there, B is there, this already we have drawn it. So the remaining is C, D, E, F. So now second one is nothing but this one. So now E to F. E to F is nothing but 2. Now what will happen? Next step, this is the first one, this is the second one, third one I will write it here. So write it as it is, A, B, C, D, E, F. So already you have drawn, this is 1, this is 2. Write it here also, 1, this is 2. Now what will happen? Now nothing but the D, E, F. So this is nothing but B to C. Here I have to draw. First step. And second step is A, B, C, D, E, F. So B to C we have written it 1. So now this is nothing but the E to F is 2. E to F is nothing but 2. Second step. Now what will happen? A to B. A to B is nothing but here. A to B 3. 2 steps I wrote it here only. And next step I will write it next. Third one. A, B, C, D, E, F. So this is already we have drawn 3, 1, 2. So now up to 3 over. Now what is the next element? So this is also over. So now what will happen? This is also over. Now C to F is 4. So C to F we have to draw. C to F. So we have C to F 4, D to F 4 is there, B to F also 4 is there. So in this one we have doubt now which one to be taken to the consideration. You have C to F also 4, D to F also 4, B to F also 4. So when you are taking the adjacency matrix, which one will be coming first? So B to B node will be considering first. That's why we will be taken this one. This to be taken first. So now draw here B to F 4. Now again go back there. You have what will happen? One more 4 is there, one more 4 is there. So B over. Now C to F you have to take. So now C to F if you take, what will happen? If I draw this, you will get the cycle. So we should not take C to F. Next to D to F is there. Now you see here in the diagram D to F, is it possible to draw? Yes, we can draw it here. D to F we can draw it now. So now what will happen? D to F drawn. So D to F drawn. Now what will happen? A to F is there, A to E is there, C to D, D to E. So now whatever you drawn here, you will get the cycles. So either you draw A to B, A to E, C to F or D to E, whatever you drawn, you will get the cycles. So what will happen? We cannot take that nodes. So now try to write the minimum cost of the spanning tree. A to B, A to B 3, B to C 1, B to F 4, F to D 4, F to E 2. So now this is what the spanning tree. So what will happen? 6, 10, 11, 14. Minimum cost is equal to 14. So this is what the spanning tree for this. Right. So here I have took 5, that's why 15. But in this case the diagram I have taken different number, 4 only I have taken, that's why one number is different. Otherwise it will be the same only. So spanning tree diagram is Prim's algorithm or the Kruskals algorithm, both will be the same. So these were the Kruskals algorithm. Now whenever you are having now, so this is what the trees we have taken. Now tree is nothing but this one. So now how many edges will be there? So how many nodes are there? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 nodes are there. Now how many edges will be there? In this case 1, 2, 3, 4, 5. So how many nodes are there? That how many edges are there? So n minus 1 edges will be there for any spanning tree. So that sometimes they will be asking the Viva, so that you can remember it. So in a spanning, if you have n nodes, if n nodes in a tree, we have n minus 1 edges. So you can count it 1, 2, 3, 4, 5. So how many nodes are there? 1, 2, 3, 4, 5, 6. 6 nodes are there, 5 edges will be there. So this is what the Kruskals algorithm. So Prim's and Kruskals algorithm differences is nothing but what now? So the way of solving is nothing but bit different. There will be solving always the first node, but in this case what will happen? Will be cost, all will be writing the ascending order. In that case what we will be doing? Ascending order will be writing. So 1 1 will be taking. So according to ascending order we will be connecting. Wherever you are getting the cycles, we will stop it and we will go to the next node. So this is what the spanning tree. So minimum cost spanning tree is nothing but, so using the greedy techniques we are finding the minimum cost spanning tree. Minimum cost spanning tree is also a tree which we should not have any cycles. So spanning tree is nothing but that one. So with cost we will be solving minimum cost spanning trees is Prim's, Kruskals, Dijkstra's. But without cost spanning trees we are drawing is DFS and BFS. So sometimes they will be asking the Viva questions also. So can you list out what are all the without cost, what are all the techniques you have learned it? That is called the BFS and DFS. But in this case Viva, if they ask you, can you list out what are all the spanning trees with cost you have drawn the spanning trees, is nothing but Prim's algorithm, Kruskals algorithm and Dijkstra's algorithm. Now what you have to do is, we have to write the algorithm for this also. Alright, this is simple. Algorithm Kruskals G. This is what the input. So the given graph is nothing but, you can write it, G is equal to set of the vertices and edges. Set of the vertices and edges, you can write it. So now we have to write the minimum cost spanning tree for this. So this is also very simple. So here is, previously we wrote it vertices. So we have to start from the vertices, always the first node. But here not required that one. So that's why no need to declare initial values. So initial values E of t. So tree is nothing but initially 0. Now what will be taken? I will be taken the edge counter. Edge counter is equal to initially 0. These are all the two variables we have taken initialization to solve the problems. This is what both are the null values. Now what will happen? One more variable is, I will be taken k. K is equal to 0. Now put it into the loop while edge counter is less than or equal to modulus of v minus 1. So v is nothing but how many vertices are there. So edge counter is nothing but the initially you have taken 0. So 0 is less than modulus of v. That's what just now I told. How many, if you have n nodes, how many edges is required for the graph to draw the spanning tree is nothing but n minus 1. So that's why this statement also same thing. Edge counter initially 0, modulus of v minus 1 you have to take it. So that means what will happen? If you have n nodes, n minus n edges will be drawn. So next one is nothing but k is equal to k plus 1. Increment k is equal to k plus 1. Next, right. So what will happen if E of t, this is nothing but the variable whatever you have taken edge of t, union E of I comma k So initially what will happen, k, you have taken k is equal to k plus 1, you have taken here. So I comma k, what will happen is nothing but, so 1 to 1, 1 to 2, 1 to 3, 1 to 4, 1 to 5 rows and columns. So entire diagram will be taken which is the minimum. So that is, it should be acyclic, is acyclic. So acyclic is nothing but what? Already definition I told you, minimum cost spanning tree is nothing but, minimum cost spanning tree is also a tree which we should not have any cycle. So if it is a of I comma j, whatever you have taken the minimum element, that should be acyclic, then only you can consider that one. So otherwise it is not possible. So if you are considering that, so that you make it the union. So E of t is equal to E of t union E of I comma k. So this is what the algorithm over now, Kruskals algorithm. Now what you have to do is, edge counter you increment by 1, edge counter is equal to edge counter plus 1. So now written E of t. So now once again I will tell you, this is nothing but the edges of the tree. How many you have to draw the spanning tree, how many edges? Initially I don't have anything. So edge counter is equal to 0. Edge counter is nothing but what? So how many edges you have to draw that one, that is the that purpose. Now k what you have taken, so I is nothing but the rows, k will be representing the columns. So here I comma k. So E of t is equal to E of I comma k. So in that entire graph, if it is you are taking the minimum element, in that which is not having the cycle, so that element will be taken. So once you found that acyclic, then you add it, E of t is equal to E of t union of E of I comma k. So now what will happen, once you drawn that spanning tree, once it is connected that node, now edge counter is equal to edge counter plus 1, written E of t. So this is what the Prim's algorithm and Kruskals algorithm. So Prim's, Kruskals solving is different, but finally we will get the answer is same. So that is the differences. So difference is nothing but the, we have the Prim's algorithm and Kruskals algorithm. So Kruskals algorithm is nothing but what will happen is edge based algorithms. Prim's algorithm is nothing but the, so heap faster than the Kruskals algorithm. So these were the differences between the Prim's and Kruskals. So next class we will see the Dijkstra's algorithm. So thank you. These were the Prim's and Kruskals algorithm under the greedy technique. Thank you.